Hello again, everybody. CJ here, your local friendly technology addict, and this is the Tech Addict Addict. So I've been at this for 2 hours tonight to do a 10-minute segment, and I'm cramming too much garbage in, and there's no way for me personally, because this is not how I work. I go off on tangents. There's no way for me to cram everything into 10 minutes, so I've broken this one into 2 videos. And this is the second, third, fourth take of just this half of the... So it's 1 o'clock in the morning here, and I'm getting up in 5 hours to go to work, and it's going to be yet another day for me. So here's what we got. Crystal radio. Why is it called crystal radio? Well, it's because back in the very earliest days of radio, the earliest days of electrical engineering, you had a rock. Okay, now it didn't actually look like crystals. I just drew that to, make it look like you know what I'm talking about. Now, this rock is sitting in a pool of molten lead. That molten lead cools off. They've got a wire coming out of it that becomes a lead, and that lead into that wire gives you an electrical contact with the base of the rock. Well, that's only going to be any use if the rock itself has electrical properties, and it does. Okay, so one of the electrical properties that it has is if you take a wire, very thin wire, we'll call it a cat's whisker, and you poke the rock in various places, you'll eventually find a place that makes what we call a point contact. You wind up with a wire and a single point of the wire. Now, it's got to be a very fine wire, and it'll make a single point contact with that rock. You wind up with what amounts to an electrical one-way valve. If you imagine electricity being water, it'll allow the electricity to flow in one direction but not the other, just like a check valve would do in plumbing. So, in modern days, we call that a diode. Now, the reason this is important is because it allowed people to do other things. They could use, for instance, a razor blade and do essentially the same thing. The razor blade they would put and light with a fire or a candle or something, right? With its little drips. They would use that candle to blue or anneal the metal. And you'd wind up with something close to this. You see those purple and blue and yellow in there? That's from fire. And the rust is because I've burned off all the protection that this razor blade had. And then what they would do is they would attach a wire like you saw on that razor blade, and they would take a pencil, and the pencil they would trim away some of the wood from the end, just like I've done here, and they'd wrap a wire around, and that wire would become a lead on the pencil. So you'd have a wire from the razor blade, a wire from the pencil, you put the two together, and you wind up with this point contact thing. Well, why don't we keep doing that? Well, it's cumbersome for one thing, but for another thing, it's incredibly unreliable. For instance, you have to keep poking and poking and poking and poking and poking until you accidentally, basically, come across the point that works like a diode. And you so much as look at it sideways, and it's going to, and now you've lost your diode. It just goes to another point on the rock or whatever, and you don't have your contact anymore. Everything goes haywire. You don't have any more signal coming through. So we use diodes today because they are reliable. They're commercially manufactured. You get the same results every single time. You don't have to worry about hunting for that magic spot. They've done that for you. It will work, guaranteed. So that's why we use diodes for crystal radios, because they have the same properties as a crystal radio. Now here's the problem with a diode. With a diode, your input voltage, let's say 1 volt, let's say that 1 volt is right here. Inside the diode, you have a certain drop. And let's just say that that drop is 0.6 volts. Well, that will bring you down to 0.4 volts. All right, so in, out. The difference here being, and we call this forward voltage or a voltage drop. Okay, and the reason the reason the two terms are identical is because you have to have, in order for any voltage to come out. Okay, let's say this is 0.000000001 volts. In order for any voltage to be on the outside of this, you have to have at least this much voltage here going in. So that's why it's forward voltage. Once you hit that 0.6 volts, then it will start passing the signal to the other side. Why is this important? Well, let's say that your antenna goes into a diode, and you'll notice the electronic schematic symbol for a diode looks an awful lot like the point of a wire hitting a substrate. Okay? The point of the wire hitting a substrate. This is essentially what we have in a crystal radio. Now, of course, you've also got the tuning coil and the variable capacitor and all that to make the tank circuit and all that. But essentially, if you can imagine all of that as the input to your diode, the output goes to your audio. And the problem with this is if your voltage coming in is only 0.5 volts, you can imagine how a 0.6 forward voltage diode might not pass any signal to the outside. Well, if your input signal is 0.61 volts, your output signal is going to be 0.01 volts on a 0.6 volt forward voltage diode. So that's what your audio amp is going to get, is that 0.01 volt. And that's why it's so quiet. Whereas if you have a diode that, say, has a 0.275 volt drop, well, you only need 0.275 volts going in for it to pass that to the audio amp. And that's what we have. We wind up with a diode passing a whole lot more signal to your audio amp. Now, I have here a voltmeter that I've got set to the continuity and diode test mode. And if I take this, take the leads to it, I don't know why it's being such a pest today. It was working fine earlier. You see, it's basically 0 volts. There's going to be a little bit due to corrosion on my leads, but it's essentially 0 volts. Now, if I take and measure the original diode that I was using in my crystal radio, you'll see I've got a 0.6 volt diode. Well, keep this in mind, but we've got a much better diode to be using. This one here used to be my father's diode. I claimed it. It's older than I am, so I don't like using it, but you can see it's 0.426 forward volts. But this one here is 0.276 forward volts. Now I want you to keep in touch, keep tuned for the next video that I do, because I'll show you the differences between those three diodes with regards to the signal that they pull in. And I'll also tell you why I was using the wrong diode, but we'll get into that. So for once, I finally have a video that I can go ahead and upload, and I've managed to kill my phone battery doing it too, so I've also got even more stuff to clean up now, charger and all that. But while I go ahead and upload this video, I'll do the next video real quick, so stay tuned for the next one, and I'll see you then. Yeah, it's like 1 o'clock in the morning here. I am dead up in the head. So let me get right to that.